Hello everyone. I was looking at our videos on YouTube and I noticed that although we have tutorial videos for other project ones, we don't have any specific to the Letterman project. So I thought I'd make a video to help you get started. You might have found the video from Piazza Post, which I'll do after I've got this all done, or from the hints and advice, which is on page 13 of the project spec. Some of the stuff that I'm going to do in the video will be repeating stuff from the hints and advice. Some of it will be new. I'd say that we're going to have a Venn diagram something like this, where there's going to be some overlap that are in both the video and the hints and advice, and some that will be unique to either one. One other thing about the video and the hints and advice section is be willing to go back and reread it or rewatch the video later on, because there's going to be things that don't quite make sense when you're getting started that'll make much more sense when you get to the part of the project where you're coding that portion. Another thing to remember is don't feel that you have to be ready to code every line of code in this project before you get started. Now, from the Computing Cares video, they said get started early, which they said, one person pointed out, means start reading early, start understanding early, start getting questions answered early, and then work your way up to coding. But don't feel like you have to be able to write everything in order to start writing. All of our projects in 281 are designed, and I would say well designed, so that they can be coded in pieces. And I'll be talking about specifically to this project in just a few minutes. No matter how good you are, no matter how much planning you do, there's always going to be times where you're going to have to go back and do some recoding and changing things. And in my first semester at U of M, teaching 281, the first semester I was here, when we were getting the first project ready, I thought, hey, if I'm going to help people in office hours, I should write this from scratch first. Not just look at the solution that somebody else wrote. I should write my own solution. That'll help me understand it better. So I wrote my solution, and it seemed to be working okay when I ran it on like this little test and that little test. So I uploaded it to the autograder, and I got a few things wrong, fixed those, something I had overlooked. And then I was like, wow, I'm over memory on so many of these big tests. I can't be over memory. I'm the instructor, and I'm being really wasteful. Yep, that was dumb. And I had something that I put in one of my data structures for project one, different project one from this one, but same ideas. I put something in the data that I didn't really need, and it was actually duplicated info. And so I took it out. Taking it out was easy, but I had a few things that depended on it that didn't really need to depend on it. So I'm looking at the time, it's like 1:30, 2 o'clock in the morning. And I was like, no, I'm not going to bed until I get 100 on this project. That's what a student would probably do anyway. So I changed all the code. It took me like an hour and a half or so to change the code that depended on the thing that I was stupid about. And then my memory was fine. And I've got a lot of experience coding, but still, I did a little bit of planning, maybe not as much planning as I should have done, and jumped into the code pretty quickly, and I had to do a little bit of recoding, but that happens to everyone. So when you start this project, I would say one of two places to start is either start with the command line, which is going to be a lot of modifying the code that you've seen or the code that you wrote for Project Zero, or you can start with reading the dictionary. Either one of those is a fine place to start. After that, you could do the other one, or you could move on. Now, if you do the command line but don't read the dictionary, it's kind of hard to move on. If you read the dictionary but don't do the command line, you would have to create the variables, or at least some of the variables you're going to use later on, like, hey, what's my start word? What's my end word? What routing scheme am I using? Stack mode or queue mode? Change mode is on, yes or no? So you might just make a few variables that contain those things and give them fixed values at the beginning, and then eventually you're going to have to read the command line and process that also. I'm going to talk about that in a little bit. But once you've got the dictionary read, you can start doing the searching. And when you start doing the searching, you want to pick one. Just pick one morphing mode, like change mode, I would say is the easiest. Start with change mode and get to the point where your program runs. So I'm going to read the input. And before I move on to that, I'm going to draw a little bit of the reading dictionary. One thing also, when I say reading the dictionary, start with reading the simple dictionary. And you read the first line of the file. If there's an S there, it's a simple dictionary. Now later on, at some point later, you're going to write the code to read the complex dictionary. However, what you want to do is in memory, whether it started out as simple or complex, you want to have only one data structure in memory. This is going to be a simple dictionary. So whether you read in the simple dictionary easily or you had to do some of the processing to read in a complex dictionary, what's in memory is going to be a simple dictionary. Then all of the rest of your code, it doesn't matter what dictionary was read, the rest of the code is all the same after you're done reading the dictionary. Okay, so I've got my dictionary in memory, and we'll talk about data structure for this in a minute. So I've got my dictionary read, and then what I'd do is, hey, let's start on the searching. So let's start doing the searching, and then after I got the searching done, let's start doing output. And I'm going to start out simple. I'm going to be able to say that there's no solution, if that's the case. If there's no solution, I want to be able to say that. And there's actually one more piece to it, which is, I think, something like how many words were checked. So there's something else that goes in there with the no solution. And it's how many words were checked. No solution, comma, number of words checked. So you want to get to the point where you can print out that there's no solution, then get to the point where you can print out how many words you checked, and then later on we could get to the point where there is a solution. Once you've got that much done, so you can know if there's no solution, you know if there is a solution, you can print out the no solution info, you can print the solution, then, when we do the solution output here, we would want to do word output. Let's start with word output. That's the simple one. Then, later on, we can go back and do all the things we missed. We can do the other morphing modes, which is swap mode and length mode. We can do the reading a complex dictionary. We can do the morph mode output, and they're all independent of each other. You can do them in any order you want. So when we build this project, there's a lot of room to finish pieces later on. And at the beginning, like I said, until you read the dictionary, you can't start searching. Until you've done the searching, you can't do any real output. But then we can start building up these pieces of output if there's no solution, correct output if there is a solution, and then other things like morph mode output, complex dictionary input, other morphing modes like swap mode, length mode, etc. Now, another thing about writing this project is we want to avoid using pointers. Don't use pointers in this project. It will lead you down the wrong path. It will cause you to use more memory than you need to. And I'll give you a tip later on, right at the end, I'll give you a tip of something to look for that'll tell you that you've done something wrong. So we don't want to use pointers in this project. Trust me, when we get to project 2, you'll have enough pointers. You'll be like, okay, I'm ready to do things without pointers again. So we don't want to use pointers in project 1. It really leads us down the wrong path in terms of good memory usage. So what we want to do, we also don't want to use C strings. We want to use string objects. So like when we read in the dictionary, however, we're going to come back to this one. We're going to read in strings, and we're going to store strings in memory. And we're also going to, if we need to, we're going to pass things by reference when we have to. And there's going to be a section in, I'm going to say this a lot this semester, Canvas, Files, Resources, Optimization Tips. There's a section in there, a set of 3, like if this is true, do it this way, on when to pass by reference, when to pass by value, etc. So make sure you look at that. Now, when we start working on like the reading our dictionary and processing the command line, hey, let's do some planning first. Let's talk about what not to do. What not to do. Let's not make an 800-line main with all the code in there and duplicated code. And that's a way that works, but it doesn't show coding maturity. And it doesn't do well for bigger projects. Let me give you a little, I don't remember if I said this in lecture or not. I'll give you a little background on myself. Before I got my PhD, I actually did my undergrad, my master's, worked in industry for about 7 years, and then went back to school and did my PhD. I worked for a company that we made our own hardware and our own software that went in our own hardware. And it was a digital modem. It was called an ISDN adapter. It was basically the predecessor technology to DSL. And our code base was about 750,000 lines of code. So I've done little projects of, class projects and research projects, and I've done huge projects of 750,000 lines of code. So I know what I'm talking about when I say in industry, they don't want you to do things this way. You can't have a 1,000-line main. You can have it, but it's not a good idea. And it's not easy to debug. It's not easy to check timing. Lots of things. Like I've had students in 281 say, hey, I did what you said to do about checking for timing, and all it says is that I spent all my time in main. And I look at their code, and they've got an 800-line main. Well, that's why it says main spent all the time, because that's where you spent the time. So to get a better view of, hey, did you spend all your time reading? Did you spend all your time searching? Did you spend all your time on output? You need to have functions for those. And we'll talk about those in a few minutes. But another thing not to do. So 1,000-line main is a no. Global variables. Global variables, also a big no. Global variables are a crutch. Global variables are like a 1,000-line main. It's a way to get things done, but it demonstrates a lack of coding maturity. If I was doing interviews and someone pulled out global variables in a coding interview, for me that would be that's it, that's done. I'm not going to hire this person. Because in even a 1,000-line program with a couple functions, if you have global data in a 1,000-line program and you accidentally modify a piece of global data when you shouldn't have, you can track it down. In 750,000 lines of code, and you wrote like ++x semicolon, and you're like, oh, I'll create x later after I get a compiler error. And you never get a compiler error because, hey, there's a global variable named x. And you just changed it, and you just made the whole 750,000-line program stop working. How do we find the one place where the letter X appears where it shouldn't? So that's why we don't want to start using that crutch of global data. So what's a good way to start with Project 1? Make a class. We can let's make a class. Letterman. What am I going to put in my Letterman class? I'm going to have some private stuff. I'm going to have some member variables. And I might even have some member functions. I'm going to have some public stuff. Public stuff, I might have something like a get options function. What's it going to need? argc, argv are going to be passed to it. It's going to be a void function. Why? Because it's not going to return anything. It's going to modify the member variables for things like, hey, what's the start word? Or I should say begin word. What's the begin word? What's the end word? Things like that would all be member variables. The project zero get options was something that worked for a simple project with only one useful command line option, which was the mode. Help, we just showed the help and we were done. But there was really one real command line option, which was the mode, and so it was easy to make it a separate function. Well, here, I can't return 8 variables easily. I could return a structure containing 8 variables, but an even better solution would be to have this be a class. All the things that could be on the command line, make them member variables, make get options a member function, make it void. It doesn't return anything, it just modifies all the member variables. What other member functions would I have? Things like, oh, I don't know, read a dictionary, do the searching, do the output. Now, what does my main look like? Sync with standard IO false. If you don't know why, look up the Canvas Files Resource Optimization Tips. So my main has sync with Studio false, declare me a Letterman object, process the command line, Letterman object read the dictionary, Letterman object do the searching, Letterman object do the output, return 0. I could conceivably have a 7-line main because everything else is written in these member functions. Hey, I go to read a dictionary. Why would I have private member functions? Oh, maybe read a dictionary. When I go to read a dictionary, it could be simple or it could be complex, which could be private member functions. They don't need to be public. The public world shouldn't be able to tell me what's in the file. I'm supposed to read the dictionary. I'll read the first part, whether it's simple or complex. Maybe I'll read the number. I'll take care of the comments. And then I'll call the function to finish the simple or complex part of it. Or maybe I'll just let simple and complex read the number and the comments. Not a big deal either way. Not a lot of duplicated code either way. Okay, so then we've got to talk about reading in the dictionary. So we said we're going to read the dictionary. We're going to store it in memory as a simple dictionary. Let's say another thing we don't want to do. We don't want to say, hey, remember my private member variables up here. Hey, my private member variables has got to have a dictionary. What I don't want to do I'll just say DICT for dictionary. I don't want to make a vector of strings for the dictionary. The reason is you're going to discover later that although what's in the file is just words, what you're going to have to maintain in memory is going to be more complex. And what we don't want to do, let's provide a counterexample, different program. Suppose I was making a program to deal with student data. And let's say I didn't make classes. I'm just going to make a bunch of I'm going to make a bunch of functions, no classes, no member functions. And I decide, hey, in main, I'm going to have to make a vector of student names, and I'll start writing functions, that read students. So I'll pass that function, the vector of student names. And then I get that working. I go, oh yeah, students got to have, a phone number. Okay, let's add that vector. Let's add that vector to the prototype for read a student. Let's add it to the prototype for sort the students. Let's add it to the prototype for the output students. Let's add it to the implementation of read the students. Let's add it to the implementation of sort the students. Let's add that second vector of phone numbers to the output the student. And then every time I add a third vector, I've got to go modify 3 prototypes and 3 functions. Add a vector for address, city, state, and zip code. I go modify 3 prototypes and 3 functions to add 4 more member variables. And then when I add student numbers, I go modify all those functions. And pretty soon, I've got all these prototypes and functions that have like 12 vectors passed to them. That's a terrible organization. What I should have done instead is I should have made a class or a struct of a student, one student, or in the case of Project 1, one dictionary entry. So in Project 1, you could make even just a struct would be fine. I'd be happy to see a class with a structure inside of it and a vector of that structure. Let's call it dictionary entries. So what's in a dictionary entry? Well, at the beginning, it'll just have a string in it. But later on, if we add anything to the structure, we don't have to modify existing code. We just have to add new code that deals with the new thing that is in a dictionary entry. So that's why I said we don't want to make a vector of strings. We want to make some sort of structure, and a vector of those structures would be our private dictionary variable. And then we can have the read a simple dictionary, fill that in. Read a complex dictionary fills that vector in. And if we discover later on, even after I'm done reading, I might discover, hey, you know what? Forgot. I never realized that. I got to add something to that structure. Well, it's not what's read in, so even the read might not have to change much. I might have to set default variables if I don't do it properly, or default values if I don't do it properly, but I won't have to modify read much at all. It'll still read in the words, and it'll store the words in the vector of dictionary entries. And then I've just got to make sure any other variables that I add get initialized properly by somebody. Okay, so the other thing is when we do the command line options. So the command line options, I said, for example, we'd have to remember the begin word and end word. Now those are definitely going to be string objects. The morphing modes, now this is one of those things you might have to come back to. The morphing modes like change mode or length mode or swap mode, they can be on or off. They can be Booleans. So we can have a Boolean variable for is change mode on, is swap mode on, is length mode on. One thing I don't want to do is I don't want to have a string for the is it a stack or a queue. So let's do an example, and I'll show you why we don't want to do this. If I have some code in my program that says something like this, if mode equals QUEUE. Okay, so if I have that in my code, we don't want to do this, but let's see why. If, let's say the mode was stack, I would compare S and Q and they don't match, I'm done. I know mode is not equal to Q. But what if it was equal to Q? Then what happens is, I have to say, is Q equal to Q? Yes, it is. Is U equal to U? Oh, let's move on to the next letter of the mode. Let's move to the next letter of the C string. Is that a U equal to U? Yes, it is. Let's move a forward letter. Let's move forward letter. Is E equal to E? Yes, it is. Let's move forward letter. Let's move forward letter. Is U equal to U? Yes, it is. Let's move forward. Let's move forward. Is E equal to E? Yes, it is. Move forward. Move forward. Is, hey, I'm at a \0. Am I at the end of this string? Yes, I am. Now that took 6 comparisons and 12 increments to figure out that the mode was equal to Q. That took 18 operations. If instead I said something like this, if stack mode. What type of variable is stack mode? Sounds like a bool. Now on the command line, when getOptions is processing the command line, we might have to remember a little bit more temporarily. Because on the command line, I could have -s or I could have dash dash stack. I could have dash q, or I could have dash dash q, UE. Any one of those could be on the command line. But if none of them are on the command line is invalid. If more than one of them is on the command line, that's invalid also. But once I'm done, when I'm about to leave the getOptions function, all I really need to know is this Boolean variable true or false? That's the only thing that really needs to be a member variable in terms of those options. So those options can reduce down to one Boolean variable, which takes one comparison instead of 18. Now, like I said, begin word, end word, got to be a string. But the is it a stack or a queue could just be a Boolean. Okay, now another thing about this is we're going to have to keep track of when we do the searching, and this again might be something you have to come back to later. When we do the searching, the command line says you have to work as if it's a stack or a queue. Now, let's look at what we don't want to do. What we don't want to do is write a search function, search stack, and in search stack I've got some code, and I've got I've got a stack of something, and let's call this SC. That stands for search container. That's the term the project spec uses. That's my search container, and then later on, I'm going to have to say search container dot top. And this function is going to be like 100 lines long. Then when I write my search queue function, it's going to have some code. It's going to have a queue of whatever type, search container, and then at some point later I'm going to have to say search container dot front. And all the other 98 lines are going to be exactly the same. And that we don't want to do, because I don't want to have to fix a bug right here and make a parallel change over here. And then when I fix a bug over here, I got to make a parallel change over there. You say, but there's only 2 of them. Well, what if there was only 3 of them or only 7 of them? It's a bad habit, so let's not do that. What we want to do instead is we want to have one search function. And what we're going to do is inside this search function, we're going to make a deck of whatever type. We'll talk about this in a minute. That's my search container. Now later on, I'm going to have at some point, I'm going to have an if. If stack mode. Hey, there's that if I was talking about. And this if is going to be inside of a loop. So I'm going to say if stack mode, what I'm going to say is something is equal to search container dot, okay, wait, it's a deck. I don't have a top anymore, but I've got a back. And I'm going to have to say search container dot pop back. Else. I've got to say something is equal to search container, whoops, search container dot front, whoops, need parentheses in there, and search container dot pop front. And that's the end of my else. Now later on, at some point, I'm going to have to put things in there. When I want to put something in there, I'll say search container dot push back. Now this stuff is in the Project 1, the STL&U PDF. Now look what happens. If I push it at the back, if this is queue mode, I always push to the back. If it's not stack mode, it must have been queue mode. Notice no else if here. It's a Boolean. If it's not true, it must have been false. So if it wasn't stack mode, it must have been queue mode. I push to the back, I take from the front. Well then, if it's stack mode, then I push to the back, I take from the back. It's a stack that's growing sideways instead of up and down. So the stack, or the deck, sorry, in the deck, if I always push to the back and I take from the back and pop back, that's behaving like a stack. Everything happens at the same end. But if I add to one end and take from the other, that's behaving like a queue. And now these are the only two lines of code that are different for stack mode versus queue mode. If I fix a bug, it's fixed for both stack mode and queue mode. Okay, so now, what are we going to put in this deck? We're not going to put the same thing that's in the vector of dictionary entry structures. Okay, we don't want to make it a vector of dictionary entry structures. Too much wasted info. We don't even want to make this a deck of strings. Now I'm going to tell you in a minute why we don't want to use a string here, but remember what I said earlier. Don't use pointers. So in the project spec and in the Project 1 STLMU, it says things like, add a word that's similar to according to the morphing modes. If the word is similar enough, then add it to the search container. Well, we're not really adding the word to the search container. We're not adding the string inside quote marks. We're not adding a copy of the structure. We want to add something simpler, and we don't want it to be a string. Strings are wasteful. Let's talk about why. And this is something that I hate to give you half an answer. So I'm going to show you why strings are big, but you don't need to know this for the exam or anything like that, but it's good to know. So what does a string object look like in memory? Okay, since G++ version 5 and on. So they changed it between G++ version 4 and 5. I don't remember where it was, which version of the C++ spec they recommended this, but I noticed it in G++5. So they changed how strings are stored to make them more efficient. So here is what they look like now. My picture may be slightly out of order, but the contents are going to be right. So what we've got here is 32 bytes. So a string object is 32 bytes. I'm going to cut it in half, and I'm going to cut it in half again. So what's in here? Size. And the size is 8 bytes. And then there's going to be a pointer, which is also 8 bytes. And then it's going to have a data region, which is basically 15 characters plus room for a \0. So this is 16 bytes. That's where my 32 bytes came from. So let's say I had the word test in here. So test \0, over here size would say 4, and what would be in the pointer? The pointer would point right there. Now wait a minute, what if the word that needs to be in this string is bigger than 15 characters? Well then what happens, let's just change pen colors here, then what happens is I would have, this would point there, this would say, like, let's say it was 20 characters long. This pointer, instead of pointing to that buffer, would point off onto the heap to a block of memory that's how big? 21 bytes. The last one would be a \0, and then the rest of my 20 character long string would be here, and this memory would just go unused. So this is why we don't want to create string objects when we can do something better, because they're 32 bytes at least. If you ask the size of operator, and it looks like a function when you call it, like if you say cout size of string, it looks like a function call, but you're giving it a type, not a variable. It'll say 32 and it'll always say 32. Even if you give it the name of this string that has 21 20 characters inside of it, and it's got 632 plus 21, it'll still say 32 because that's how big the object is. Size of is an operator. It runs at compile time. So at compile time, all it knows is this object occupies 32 bytes. It doesn't know whether it's going to allocate heap space or not. So a string object is always 32 bytes and maybe more if it's a long string. So that's why we don't want to put strings in the deck. We don't want to put a dictionary entry because that's a string plus other stuff. We don't want to put a string because it's big and it doesn't help us much. I want to know what word is the next word, but not put the word. So think about how you can do that, but not a pointer. So you've got to be willing to put different types of data in different data structures. So we're going to have the dictionary will be the structure of dictionary entries or whatever you want to call them. We'll have a string and some other stuff, and then what goes in the deck is going to be a different type, smaller. Now, I mentioned earlier that I was going to tell you how to know if you've done something wrong. Like if you ignored me and you used pointers, or you did some other mistake. So how do we identify, or one of the ways that we can identify that we've done something wrong? So let's say we're looking at our dictionary in memory, and the dictionary, remember this is a vector of, let's call it dictionary entries. So this is a vector of dictionary entries, and because it is a vector of dictionary entries, I'm going to draw what's inside of it. And I'm going to show you outside of it. 0, 1, 2, 3, all the way up to, let's say, 9,000. So these numbers are implicit. Implicit means they are not part of the deck. Or not in the vector. So these are not in the vector, but they're how we refer to the vector. So I said in my code, I did something like dictionary, square brackets index, dot word. Now let's say that index happened to contain 3. If index happened to contain 3, then let's split this up over here. Maybe this is the word portion. Maybe the word over here is okay, maybe word index 3 is anchovy. And maybe we've got up here, we've got A, an, A, and D. Oh, look, it's not in alphabetical order. There's no guarantee that the dictionary is in alphabetical order. So we've got A, an, and anchovy, etc. What you don't want to see, this is how to tell if you've done something wrong. If you also have over here a 0, a 1, 2, 3, and 9,000 down here, first of all, this tells you there's 9,001 words in there. But I could have asked that. I could have said dict.size. I don't have to know how many words are in the dictionary. I can ask the dictionary, how big are you? It would say 9,001. What I don't need to see is these extra copies of the indices. One reason is that the easiest way to get here is by saying dictionary subindex dot IND or something. Let's say this column was named IND. So I look up the index 3 and I find a copy of 3. And I look up index 500 and I find a copy of 500. And I look at index 9,000 and I find a copy of 9,000. This is all wasted memory. So this is one way to tell that you've done something wrong. If you find yourself having to add those in there, something else went wrong at another place in your program. Okay, so that's what I've got to help you start out here. And this is really, we're doing this to save some of the time in office hours so that we can spend time on more personal questions.